Today we're going to be talking about linear relationships, and we're going to start with slope-intercept form. So with slope-intercept form, we have y equals mx plus b. A reminder that m is the letter that stands for slope, and b is going to be the y-intercept. Okay. Here at the bottom it says a line with a slope of 8 and a y-intercept of -10 would have the equation of, we would have the y equals, our slope is 8, so we're going to put 8, right? And our y-intercept is -10, so we'll have 8x. You can have plus a -10, or we can have just a -10, right? An equation of y equals -3x plus 5 means that the slope of the line is blank and the y-intercept is blank. So we know our m is always with our x, our slope, our m, which is our slope, is always with the x. So our slope of the line is -3. Notice I didn't put -3x. It's just -3. And then the y-intercept is going to be 5. Right, because it is a positive 5, so it would just be 5. Let's go ahead and look at the writing equation. So we kind of wrote equations given a description, but let's do it with a graph here. Okay, so to find the slope, we're going to be using y2 minus y1 over x2 minus x1, or you can use rise over run. We did review this, so it should be fresh on your minds. Step number 2 is find the y-intercept by finding the value of y when x is 0, or where the graph line crosses the y-axis, right? Step number 3 is write the equation in slope-intercept form, which is y equals mx plus b. It's called slope-intercept form because it has the slope and the intercept. Right. So let's look at 2 examples on a graph and a table. The first example is a graph. We're going to find the slope. So we can do the y2 minus y1 over x2 minus x1, or we can do the rise or run. Here, I'm just going to do the rise or run. Luckily, they already lined up 2 points for me that I can use. Notice that they're perfect points. They're no 0.5. It's not 0.1, 2, 3. They're just 2, 2, 2, and 4, 3, right? So from left to right, I'm going up 1. So I know my rise is 1. Let's put rise over run. My rise is a positive 1, right? And my run is 1, 2 to the left, to the right. And to the right is a positive, so we got a slope of 1/2, okay? So let's just go ahead and put that it is 1/2. The y-intercept is, again, step 2. We find the value when x is 0 or when the line crosses the y-axis. So here we can see it crosses here at 1, so the y-intercept is 1. Okay, and together we can write the equation. Remember, it's y equals mx plus b. So I'm going to replace the slope with the m and my y-intercept with the b. Okay, so my answer is y equals 1/2 x plus 1. Right, let's look at writing an equation given a table. So here the table is, we have x values 0, 2, 4, and y values -9, -1, and 7. Okay, to find a slope, we're going to find the change of y over the change of x. So the change of y between -9 and -1, we are adding 8, right? So my change of y is 8 because this is the y column. And then from 0 to 2, we are changing by adding 2. So our change in x is 2. 8 divided by 2 is going to give us a 4. Right? Or 4 or 1 if you still want to keep a fraction. Okay? Our y-intercept here, there's no line, but we can find the y-intercept by finding the value of y when x is 0. Okay, so here when x is 0, y is -9. That means that like on a graph, here at -9, it's crossing there, right? So our y-intercept is -9. Oops. Okay, so just like the other one, we have y equals mx plus b. Our y-intercept is going to be b, and our slope is going to be 4. So let's replace those. We got y equals 4x plus a -9, or we can just put -9. Now let's go ahead and go to proportional relationships. So the relationship is proportional if there is a constant rate of change. So let's look at like a t-chart with proportional and non-proportional. So in the first bullet point, proportional graphs, they contain the origin and is linear. Okay, so that means that they cross, like you have a graph, they cross the origin at 0, 0. Okay. For non-proportional in a graph, that does not contain the origin and is not linear. Okay, so that means that if you have a graph here, it's starting there, or maybe it's going down like that, right? But it's not starting at 0, 0, okay? Now let's look at the table for proportional. So a table that has a constant ratio of y over x, okay? And that's what we're looking for, y over x. And then on the other side, non-proportional, they do not have a constant ratio of y over x. Okay. And that's just getting the y values and dividing by the x values and seeing if they have the same number all throughout. Okay. In an equation, for a proportional, it does not have an addition or subtraction that is written in the form of y equals x. Okay. Or kx in case there's like a number. Right. And this right here is a number. Okay. So an example, this can be 3x. That is a proportional relationship. An equation that's non-proportional, it's written in the form as y equals mx plus b. Okay, where b can't be 0. Okay. So if you're given y equals 3x, that is proportional, but if you add like a +9, then it becomes non-proportional. Why? Because this +9 means that it's not in the origin, it's up on where y equals x. Or sorry, y equals 9. Let's go ahead and look at direct variation. We didn't really talk about this, and it's okay. It relates to proportional relationship. Or we did talk about it, but it wasn't that much. So we always look for the term if y varies directly with x, that is called proportional, right? Where y equals kx, k is a constant proportionality, or the constant of variation. Okay. It's that number that kind of like that example that we did here, that y equals 3x. This is that k. Okay. And to solve for k, you divide y divided by x.